Hello, Algebra 1 students. This is your last set of notes for the school year. We are almost done. And previously in our last target 4A, we had learned about the special forms of linear equations and pulling out all of the important information from those linear equations. And now we're going to be using that information to graph these linear functions. So when we are trying to graph the solutions of our linear equations, we have to understand how these solutions arrange themselves. Since they do have a rate of change, or otherwise known as a slope, that's always constant, then that means that the points start to form a line. This is why they are called linear equations. As you can see, the word line is in the word linear. So now in order to graph this line, we have to know two important pieces of information from the equation, because in order to make a line, we have to be able to connect at least 2 points. So there's two different ways that we can get this information. So the first is if we have a slope represented by which letter? That's right, M, and a point on the line. So that might be if you are using slope-intercept form. Your point or solution would be the y-intercept, and then from there you would graph the slope. The second would be if you are given 2 points on the line, or 2 solutions, and these points will be called the x and y intercepts, and this will only be used in standard form. Okay, so here we go with our first example. So our equation is y equals negative 5x plus 13. So this is an equation in slope-intercept form. And actually, I'm going to change this equation a bit just so that it fits on the graph better. So this is going to become y equals negative 5x plus 3. So this is an equation in slope-intercept form, and our y equals mx plus b. So we need to be able to pull out m, which is the slope, and b, which is the y-coordinate of the y-intercept. So let's start with the slope. So our slope is the number that's being multiplied in front of x, so that would be negative 5. And b is going to be the value of 3. So how does this help us graph our equation? Well, the value of 3 is the y-coordinate of the y-intercept. So this can actually go one step further and become the y-intercept. That y-intercept is going to be our solution that we graph as our first point. From that y-intercept, we are then going to use m equals negative 5 as our slope to give us our direction for our next points. So in order to graph this as a rate of change, I'm going to put this over 1. So we have negative 5 over 1. What this tells me is that my slope can either go down 5 and right 1, or we can have 5 over negative 1, which will go up 5 and left 1. Okay, let's start by graphing our y-intercept. So we're going to put our first point on the line at 0, 3. From there, I'm going to go down 5, 1, 2, 3, 4, 5, and right 1. I'm going to keep going with that slope until I can't graph any further. Now, for my original y-intercept of 0, 3, I can also count up 5 and left 1. So you can see that my points are on a constant slope, and I can connect those points to form a line. Now the green points don't just represent the only solutions of the equation. There are an infinite amount of solutions on a line, and every single point on the line represents a solution. Okay, so now let's get to our characteristics, starting with the domain and the range. So the domain is what's happening with my graph as it goes to the left and to the right. The left side of my graph is going forever to the left, so it's going to negative infinity. And the right side is going forever to the right, so to positive infinity. So our domain is going to be from negative infinity to positive infinity. Our range is what's happening with the graph from the bottom to the top. So as our graph goes down, it's going down to negative infinity. And as we go upward, it's going to positive infinity. So our range is negative infinity to positive infinity. There are no holes in the graph, no breaks, so our domain and range is going to be negative infinity to positive infinity for every linear function as long as it is continuous from left to right. Now, on to the y-intercept. Well, we already know our y-intercept right there, 0, 3, because that's where our graph crosses the y-axis, and that was given to us in our equation. The x-intercept is a little bit trickier. The x-intercept is where's our graph crossing the x-axis, and that point is right here. Now, I know that that point is on the x-axis. So what I know about that point is that its y value is 0. So I'm going to try and figure out what that x value is now that I know that the y value is 0. So here's how we can figure that out. To find the x-intercept, I'm going to take my equation, y equals negative 5x plus 3. And since I know that the y value is 0, I'm going to replace y for 0, and I'm going to solve for x. So I'm going to try and get x by itself. So we'll first subtract 3. So we have negative 3 equals negative 5x. And then divide by negative 5. So x is equal to negative 3 divided by negative 5, which we get 0.6. So that looks good. That's where my graph is crossing the x-axis. Okay, and finally, we can't forget about our rate of change, our slope, which we knew from the original equation, which is negative 5 over 1. Okay, let's take a look at our second example. Well, this example, if you would recognize, is in point slope form. So point slope form is y minus k, which is equal to m times the quantity of x minus h. So we need to identify m, h, and k. Let's start with m. Well, m is our value that's being multiplied in front of the parentheses here, so m is 3. We can't forget that h and k are actually the opposite of what we see. So h is positive 5, and k is going to be negative 2. If we put h and k together, that will give us our first point, and then from that point, we can graph the slope. So our point on the line is going to be 5, negative 2. So let's start with our point at 5, negative 2. From that point, we can now graph our slope. So our slope is not currently written as a fraction, so I'm going to write that as a fraction as 3 over 1, which tells me I can go up 3 and right 1. Or how else can I write two positive numbers so that it'll be on the same line? And that would be -3 over -1, the opposite direction, which would be going down and to the left. Let's start with up and to the right first. So we're going to go up 3, count up 3 boxes, 1, 2, 3, right 1 box, and keep going until we can't fit that any longer. Okay, now I'm going to count my slope in the other direction. So I'm going to go down 3 and left 1. And connect those points to form a line. All right, let's move on to our characteristics. So our domain is what's happening as our graph goes to the left and to the right. So as our graph goes to the left, we're going further to negative infinity, and to the right, we're going to positive infinity. Our range is what's happening to the graph as we go from the bottom to the top. So from the bottom, we're going down to negative infinity, and to the top to positive infinity. Okay, where does our graph cross the y-axis? Well, as of right now, we can't really tell. But what I do know is that my graph does extend in both directions infinitely. So if I were to extend my y-axis, I can see that my graph will cross the y-axis eventually, but I don't know what that value is. But what I do know is that value is where x is equal to 0. So in order to find the y-intercept, I can substitute 0 in for x and solve for y. Let's do that over here. So my equation is y plus 2 is equal to 3 times x minus 5. So I want to substitute in 0 for x and solve for y. So I'm just going to be doing some simplifying. So we'll have y plus 2 is equal to negative 15 and subtract 2. So y is negative 17. So as we originally plugged in 0 for x, that value we got for y is negative 17. If we look at our graph, that makes sense. Our y-intercept is going to extend way beyond negative 10, and it's going to be further negative. So 0, negative 17. Okay, how about the x-intercept? Well, I can see where my graph crosses the x-axis, but again, that's not at an integer value. So I'm going to want to do the same thing as the last example and solve for the x-intercept, knowing that that's where my y value is 0. So I'm going to take my equation and I'm going to substitute in 0 for y. And solve for x. So we'll have 2 equals 3x minus 15. We'll add 15 to both sides. So we get 17 is equal to 3x. Divide by 3. And x is 5.67. So my x value of my x-intercept is 5.67. We just want to double check that that makes sense in our graph and looks right. After the number 5, but before the number 6. And finally, our slope is what we use to count out our constant rate of change. So our slope is 3/1. Okay, these videos are getting just a little bit long. So for the last two examples, I'm going to fill them in and you guys can check back in and check your answers as you're working through these problems. Mr. Dahl also explains how to go through problems similar to these in his next two videos, but just don't want to make you guys sitting here watching videos for too long. So go ahead and try this one on your own and then come back and check on your answers. Okay, so these last two examples are done. We had one in vertical form and the other in standard form. So like I said, Mr. Dahl goes through very similar examples to these in the next two videos. So if you need a little bit more detailed explanation, go ahead and switch on over to those videos. This is just here for you guys to check your answers. As always, we're happy to meet with you over Zoom. If you want to work through any of these together, just make sure that you let us know. We miss you guys and we hope you're doing well.